As you can see, you have different sites, and not all sites are not exactly the same. I mean, this is not the same topology for the grid of the nodes. And this is interesting because if you have good results of experimentation in one type of topology, maybe it will not work as you expected in another type of topology. So all these sites are complementary. So what is exactly an IoT-LAB site? As you can see here, we have a picture of the testbed located in Strasbourg. This is a huge room in which we put all our sensor nodes in a grid, in a regular grid. This is one way we choose to deploy the node in Strasbourg's laboratory. But we have another type of deployment, like this one, the sites of Lille, which is not so dense as you can see. And they also move some nodes inside corridors. So Fabrice talked previously about some results of experimentation in FIT IoT-LAB. So he was testing his protocols inside the grown-up sites, which deploy nodes inside corridors. So this is the intermediate level, I think, between a dedicated room and a realistic deployment. So what offers the FIT IoT-LAB to the user? So this is a testbed which can allow you to launch reproductible experimentation. This is, I think, the most important thing. Why? Because you can use the same setup across lots of experiments. You can choose the same nodes with your same firmware, with the same monitoring parameters, and you can launch it as much as you want. And you can do it by yourself because it's fully automated and it's available 24/7. So we provide you a remote access via the internet, and you can by yourself launch your own experimentation. What you can also do, you can launch experiments across different sites. You can, for example, use the site of Lille and Strasbourg and use internet to forward traffic between the two sites. What is also very important for you to know is that the access is free for everyone. You don't need to pay to register and to launch an experiment. So it's also free for academic people like researchers or industrials. So why we want to do that is to be is still in the matter of reproducibility. All people publishing some results can share the work, and another people can test what you did. So this is very important to be free in order to get the access for everybody. As you can see, since the beginning, we gained lots of users, and now we have more than 5,000 users, sorry. Lots of people are from France, mainly. The half of the register are from Europe, and the other half of the people are from the rest of the world. And more than 200,000 experimentation have been already launched on the testbed. So we have now a strong visibility in the community. So now let's go more deep inside the equipment. I will now show you the device we provide for the user. So the nodes have 3 logical components. The gateway, which is used by the infrastructure in order to deploy your firmware. the control node, in order to monitor your experiments, in order to monitor the energy consumption or, for example, the radio noise in the neighborhood of your nodes. And finally, the open node, which is the node you can reprogram with your own code. What kind of microcontroller we can provide to you? Previously, at the early beginning, we have some TI MSP 430 microcontroller. And now we have some, since 5 or 6 years, some Cortex M3 and Cortex A8 processor, which are more powerful for among the same energy consumption. Dealing with the radio chip, we provide you 802.15.4 radio chip, but not only, we have also previously an open MAC with 860 megahertz radio chip. The more powerful nodes, so the Cortex A8 nodes, have some Ethernet link, so they are directly connected with an IP address to the internet, and you can use these nodes mainly for gateway purpose. So, question: how can social science researchers interested in studying human computer FIT IoT-LAB? Can we collaborate with those doing presentation? So, as you can see, the FIT IoT-LAB is just a grid where you can launch whatever you want. So you can mainly run any application you want and produce any data you want. So I think what you want to do with social science could be done if you think you can implement your scenario inside the FIT IoT-LAB testbed. So if you want, in the next question, maybe at the end of the presentation, I can detail you more in details what type of deployment or experimentation we can do inside the IoT-LAB testbed. I hope I answered to your question. So I will follow back to the slide. Now we want to evolve and use new type of hardware inside the testbed, and we want to extend our functionality with new type of microcontroller, which you can mainly buy on the market. So previously, the node I introduced you was the legacy node we designed for the early deployment, and now we want to be able to use on the market nodes, the nodes maybe you have already on your desk and you want to try to use large scale on your testbed. So that's why we open more widely the testbed to on the market nodes. The requirements in order to introduce and to integrate a new node is to be able to have a connection with USB, and to be able to flash your nodes with a Linux toolchain. And we can think about then to integrate your nodes inside the testbed. So we have a lot of documentation on how to do that. Another functionality of the IoT-LAB testbed is the mobility. So we have not only static nodes inside the rooms of the experiment rooms, but we have also robots wearing nodes, and they are moving inside the room with reproductible trajectories. So you can design a trajectory inside your room, and the nodes will keep moving as long as you want on this trajectory. So this is the first level of mobility. And then we are implementing a mobility model which introduce some randomness or some different mobility model like Manhattan mobility model or something like that. And the final level is the user control mobility. So the things on the top of the robot, so the IoT device, should be able to give some order to the robots in order to move inside the room. So this is the final level we hope we can reach. Now, what are the tools in order to launch large-scale experimentation? So, as a user, what you can do is to deploy quickly a firmware across hundreds of nodes. So this is very fast to reprogram all the nodes you booked for your experiment. And when you start your experiment, you can build some profile of monitoring, and automatically it will log for you the energy, the radio level, even Wireshark or TCP dump radio capture. And we have some also software-defined radio nodes you can use in order to sniff the radio. As a user, you can also access to the serial and debug port of the boards, of the nodes. We provide also you a workspace for your development, so you can compile your code directly on the server of the testbed, or you can deploy on your own computer a virtual machine with all the tools and the library you need in order to build your application for the IoT lab. Also, we provide public IPv6 networks in order to interconnect your application. If you want, for example, if you want to deploy a RPL network, you can use public subnets, and we route all the traffic, we forward all the traffic to the real internet. So you can interconnect, for example, the nodes of the FIT IoT-LAB with a server somewhere in the internet through IPv6. So I already said we have some mobile nodes, and we also provide some LoRaWAN infrastructure if you want to play with LPWAN networks. So we do a lot of work in order to port some OS, embedded OS, for the legacy nodes of the platform. So mainly all the academic operating system for Internet of Things are ports to the FIT IoT-LAB, so you can easily port your application on the testbed. But you can also use your own firmware. So I mean, you can test your own OS operating system. If you have developed something by yourself, it will you can try to launch it on the platform. So we have some specification of the legacy node if you want to try to port your own software. For the more powerful nodes, I mean the Cortex A8 nodes, this is some nodes which run Linux operating system. For these nodes, we provide a special version of Linux, which is called the Yocto Linux. And we have all the recipes you can use and to extend if you want to port, for example, new package in image. So we have the details here on the links. So if you want to be more efficient in your experiment, we have a REST API in order to batch your experimentation. So at the low level, you can directly talk to the REST API. You can even develop your own tools with your own language if you like. But if you don't like to code everything from the beginning, we provide you some tools. We package some tools. For example, we have some CLI tools in order to access to this API. And for the early user, if you want to start on the testbed, you can use the web portal for your first experiment. And next, in order to automatize everything, you can quickly move to the CLI tools. So if you want to collect your data, usually people develop some firmware which prints some information on the serial port or the debug port. And that's why we provide some tool to aggregate the results, for example, with the serial aggregator tools. And we provide also some tools to graph the results for example, the energy consumption or the radio noise. So if you are at the early stage of the application development, you can also access to the remote debugger, so you can launch a GDB console and start to debug step by step on all nodes remotely. You can also turn on some nodes into a sniffer, and all this node will produce some TCP dump pickup capture packets. And if you run multiple nodes in the sniffer mode, you can aggregate all the results with this kind of tool, the sniffer aggregator. We also provide tools for radio characterization. So this is very important to understand the radio technology for the subset of resource or nodes you will book for your experiment. So in the beginning, maybe you can try to understand the radio links more accurately with this tool and see the performance or the interference of the testbed before interpreting your own results. And finally, we also have a broker for MQTT or Leshland broker. So those brokers can be used also to forward data to the internet. Okay. So this is the global overview in order to sum up the usage of the platform. So you can access to the API in order to design and launch your experiment. And once you launch the experimentation, you can also connect to a server, a front-end server through SSH in order, for example, to interact directly with the nodes, with the serial port of the nodes or with the debug port of the node. So maybe more for students or beginners, how to quickly learn the usage of the platform. So after more years, we built some tutorials, a lot of tutorials for people. And now we are providing a Jupyter Notebook in order to test step by step all the functionality I explained to you before. And last year, we also launched the first version of the MOOC IoT with MCU. So this first session is over, but we will plan to open a new session in 2021. So here is the links if you want to look about the topic we can provide you on this MOOC. And all the practical courses of this MOOC will be done on the FIT IoT-LAB testbed. So let's talk about the community. We have the main website, and on this website we have a lot of information of, for example, the deployment, how many nodes on which site, and so on. We have some links about the publication. So the platform is free, and the only things we we ask for people using the testbed is if you have some publication and some results done with the platform, please just tell us your publication in order we can reference your publication on our websites. So lots of publications have been done since 10 years on this testbed. So you can have a look on the Google Scholar profile. We have also a GitHub organization. On this organization, we have almost all our work published. All the repositories are almost public, and you can get all the source code of our tools. And we have also a mailing list for users. Question, how does the sniffer aggregator work? So, as you can remember, each node has three components, the gateway and open node and control node. So the sniffer will use the radio chip of the control node, and it will transform forward all the radio messages, all the radio packets which can hear on the radio chip, and you will transform them in the PCAP format, and then there will be forward on the serial port of the control node, which is available remotely via an IP. Of the gateway component of the node. So if you look on the website, you have this detail which is explained with lots of graph. Okay, so I have finished with the presentation of the functionality of the FIT IoT-LAB. So now what I propose you is to launch a demonstration. So today the demonstration will be on the video. So first I will explain you the demonstration, and then I will comment you the video, and we can see together. So the goals are now to deploy a realistic wireless software network on the testbed, on the FIT IoT-LAB testbed, and we will try to read the value of the sensor, of the light sensor. We will also build a live multi-op network, and we will see how we will build these networks. And we will also book mobile nodes on our experimentation, and we will try to see the interaction between static and mobile nodes, how they can interact with the same firmware and radio protocol. So for the setup, we have used the Strasbourg site, and we book 68 M3 nodes. So this is some kind of constrained nodes, and 4 of them are mobile. We choose to use the Contiki OS embedded operating system, and we use a collectory protocol for the routing. Protocol, which is a dynamic routing protocol, and it also allow a multi-op topology. And finally, in order to look at the events of the network, we build a dashboard in order to show the radio links and to show the value of the sensor of the sensors, and also to see the location of the mobile nodes. So what will be the steps first of the video? first we will schedule the experiment, then we will launch the experiment, and we will observe the build of the network. And during the experimentation, we will turn off the lights of the room of the experimentation, and we will see the value of the sensor, which will change during this turn off of the lights, and then we will turn on again the lights. So this is the overview, the screenshot of the application. So now, if Nicola can help me to launch the video of the demonstration.
Yeah, we'll launch it here directly. So
I hope it's okay for you, or not?
Can you hear us? Can you hear us?
Yes.
Okay, perfect. Yeah, I will launch the video.
Okay, thanks. I don't know if you have some other question for. So the video is also available on YouTube. If you want to see it offline, you can see it. You can find it on YouTube. There is the links on all the presentation.
Can you see it? Yes, right.
I have no feedback. Sorry, of the video.
Okay, wait. Okay, well, I will restart it because it did not start in the, for you in Zoom, you probably did not see it because the other share is still on. Could you briefly switch to this computer again? Okay. Where's the mouse? Okay.
Okay, yes, okay.
Okay, it was there before, but you had to actively click it. My problem is now that I don't know how to rewind it. I will have to find that out.
Okay, yes. Well, I can follow on.
Yeah, no, it's fine.
Okay.
It's fine. I will go back. Okay,
perfect. Thank you. So this is the Collect Light demonstration running on the Strasbourg testbed, on the FIT IoT-LAB testbed. So this is another view of the remote testbed. So there is lots of nodes. We are currently do some renewals of the nodes, but we will focus today on the M3 nodes, on which we will try to run our first experiment. So I'm logging to the web portal, and I will schedule my experimentation and enter the parameters of the experimentation. For example, the duration, 60 minutes. I want to start ASAP, or I can also schedule later my experimentation. Then I will choose the nodes, so we can precisely set up the nodes we want to use by the ID of the nodes, for example, or by the architecture of the nodes, if you don't care about the ID. So there's lots of different ways how to book the nodes. So now we will book the 68 nodes. So as you can see, I directly fill up the ID of the nodes. And then I add them to the experiment batch. And I will directly choose the firmware I previously uploaded to the web portal. So this is the firmware I compile either on the server or on my desk. I also will set up a profile monitoring in order to, for example, study the energy consumption. And I submit my experiment. So now it's waiting, so I want to launch it ASAP. So as you can see, it's automatically refreshed and it's a launching state, sorry. And quickly it will be running, I think so. Voila. And as you can see, we booked it for 1 hour, 60 minutes. So now it's running. We have some details we can access via the web portal. As you can see, all the nodes seems to be successful launch with the right firmware. In parallels, we have set up also mobile nodes with a given trajectory. So we have some additional setup in order to provide some trajectory. So you can see the robot is moving and wearing on the middle, on the top of the robots, the IoT nodes of the FIT IoT-LAB. So you can interact with the API, with the REST API, with the robots in order to set up the trajectory and so on. So we have 4 robots now with predefined paths. And once it's okay, I think we will switch to the dashboard. So they are moving. So as you can see, we have some webcams also. You have access to the webcam in order to see if everything is all right with the robot. Okay. So they are on the path. Okay. So this is a very simple path. Just a line, point A to the point B. So this is a very simple example with four mobile nodes. You can set up, of course, some more complicated trajectory if you want, but for the demonstration, we have something very simple to understand. So on the dashboard, you can observe you have the 4 moving robots, but you have also lots of orange boxes. So this is the M3 nodes you booked. And now we have launched, we have started the application. It was waiting for an event on their serial ports. And now they are starting to communicate together. So as you can see, all the blue links are the radio links, which build the topology of the network. I remind you, it's the collectory protocol. And we arbitrarily choose the red box on the top of on the right top of the room, which is the root of the network or the gateway of the network. So all the traffic of the nodes is forward wirelessly with the radio link to this node, and you can use this node with the serial port in order to get the information of the value of the sensor of the network. So this is a dynamic routing protocol. So during the life of the experiment, some paths are changing. The protocol try to converge and to change and choose the best parent. So when you are far from the sink, so you can see there is a gradient of distance from the sink with the color on the top, on the bottom right. And more far you are from the sink, the more unstable are the links. So you can observe this live on the demonstration. So we will switch the information of the dashboard, and we will show you now the value of the sensor, of the light sensor of each node of the test bed. And so this is a yellow color, and the level show you the intensity of the value of the sensor. So if you remind, all the lights were on inside the room at the beginning of the experimentation. That's why we can see the yellow is very high. It's a strong yellow. So we will wait a little bit, and after that, we will try to switch off the lights. As you can see on the webcam, we just switch off the lights. And what you should now observe is the latency of the refreshment of the value of the node on the dashboard. So you will see quickly on the dashboard, in the neighborhood of the sink, on the top right of the dashboard, the value of the sensor will quickly change because they are one hop far from the sink. And more farther you go, when we are 2 hop or 3 hop far, so just observe now, you have the latency of the different routers of the networks, which just you can observe. So one hop is very fast, and each hop adds some latency for of the value from the dashboard. And of course, some messages are also dropped by the protocol and the routing protocol. You have some more delay from some of the nodes, which are very far and which lose a lot of packets during the experiment. So now we go back and we switch on the lights. And when we will see the dashboard again, just please also look at the mobile nodes. You can also see which parent the mobile node is currently using. I'm not sure if it's very easy to show that on the stream, but if you see in details, you can see, according to the location of the mobile nodes, you will choose another parent for your mobile nodes. So this is very interesting for mobility protocols. If you want to handle mobility, this is the main purpose of robots. You can do it. You can try to experiment this on the testbed. So this is the end of the demonstration and the final view of the room in Strasbourg. Voilà. So, thank you for your attention. If you know, you can switch to the question. If you have some question, feel free to ask. I'm ready to answer to you.
Okay, perfect. Thank you very much for the wonderful presentation. As before, we do 5 minutes in the breakouts. You will also be assigned to one, so feel free to discuss with the 5 people that you have.
So we can't hear you very well, Marc-Olivier.
Can you hear me better now?
Yes, thank you.
Okay, yeah, it was not switched on. Thanks for the hint. Yeah, I said thank you very much for the great presentation. As before, we'll just put the everybody into the breakout rooms. You will also be assigned to a breakout room. You can discuss, and everybody has 5 minutes to discuss, and then afterwards we come back to the questions and answers. Okay, see you all in 5 minutes. Okay, 15 seconds until the groups are back. Okay, so welcome back to the plenum. Yeah, so as usual, I ask the first question, and the first question is, what is the most difficult task when maintaining such a testbed? Is it users breaking everything? Is it hardware breaking? Is it the lock-on system? Is it unhappy users? What are your experiences?
Yes, good question. So this is lots of different things there is a lot of different tasks in order to maintain such a large platform, because you have the infrastructure, I mean all the network infrastructure to provide, to connect, to interconnect all these nodes. And then you have the hardware itself, which sometimes break down. And you have also the server to maintain, to keep up to date, and to keep also to make your development up to date. So this is one part which is lots of time consuming. And when you talk about users, what we observe, people are not breaking down the platform. I think the node we are currently using are very handy, because we can easily restore them. So from the user point of view, you can do what you want. You won't break it easily, I think. Mm-hmm. So it's okay. Don't be afraid. You can don't be shy. You can do what you want.
Okay.
But so I think it's more a software problem now, to keep up to date the development and to add new functionality, maybe new technology, as I can see, new Wi-Fi technology, for example, new standard, to introduce this into the platform.
Yeah, that was actually the one question from the chat. I guess you saw it. It's how do you update the platform and new protocols or new technology in it?
Yes, so we start at the early beginning to deal with 802.15.4 networks. So it was, I think, a requirement for the researcher. Lots of application and networking protocol on the top of this technology. But now we want to extend and to enlarge the panel of the technology. And so what we want to do is to use on-the-market nodes. And I think the best way to extend the platform is to find new development boards for manufacturer, for chip manufacturer, and to integrate this node inside the testbed. So this is the way now we extend the functionality. We are using on-the-market nodes, and we want to provide them either at large scale. For example, if you want a dozen or 100 of nodes, new type of nodes, we can try to invest this kind of new hardware. But some people are using lots of different type of nodes in order to just test, for example, the portability of the application of a new architecture. So on a new microcontroller, if it's working well or not. So that's why we have now more than 20 different architecture in order to test. For example, I think it's the Riot embedded system. They want to be running on lots of different MCU, and that's one evolution of the testbed to be to provide a lot of different type of MCU and to check if you're on the testbed.
And do you have thoughts about the possible merge with Grid 5000. Did you hear about this?
Yes, of course. So currently, I was not talking about the political evolution of the testbed. So, but of course, FIT IoT-LAB is now at the end of the project. So it will end in this year, 2020. And the next step of the testbed will be the Silex infrastructure. And it will link the network testbed, so the IoT testbed or the Wi-Fi testbed in the Equipex FIT Federation. And we will link this network testbed with a computing testbed in order to provide data center in order to compute all the data you produce with your IoT nodes. And this will be the link between the two worlds, the world of the IoT and the world of the data center. And we will interconnect these two huge testbeds together.
And maybe the last question, coming back on what you were saying about users can do almost whatever they want.
Yes.
So can you explain a bit more about this whatever and what are the limits of what a user can do?
Yes, this is the question on the chat. Yes, so you can compile what you want. So I mean, you can flash a raw firmware on the nodes. We have no limits on the compilation. So you can flash what you want on the node. So if you want something very particular, you can do it. So if you are working in an embedded system, you know, you can do what you want at this level.
So the only limit is the hardware, right?
Yes, yes.
And there's a question about, you said about cyber security. If you can test this on the platform and maybe if one day there is a certification of IoT products, if you think that the platform can be used for certification as well, including security aspect, I guess.
Yes. So currently, I know people are already testing some security protocol on the testbed. For example, you can run an experiment with a RPL network. On the top, you can have some security with DTLS, for example. But we have not certification at the end for your protocol. I mean, it's still experimental, and we have not a workbench with certification for the FIT IoT-LAB. This is not a priority for us currently in our roadmap.
Thank you.
Okay, perfect. Yeah, then I will just stop the share here. There we go. It does not come back. I hit it. Okay. Yeah, then thank you so much, Guillaume, for the cool presentation. I would also have had several more questions. I think I will contact you afterwards anyways. And yeah, we give you also a warm applause.
Thank you.
Very nice. Okay, so I will just launch the program slide again. Oh, it was, give me 1 second. Good. So, good. Yeah, so this is the slide for today. As you see, I'm not sharing it. Wait a second. Screen, second screen. Okay. So, yeah. This is the program slide for today. So as you see, the main program ended now, and at 6:30 we have a video, an interview with Windsurf that is very exciting because you will learn a lot about how the internet was designed back in the 70s. And then afterwards, we'll have a panel discussion with these two here and me, and we'll discuss a little bit about the internet architecture. You're all invited to join us in the discussion. I'm sure this will be interesting. And yeah, look forward to seeing you at 6:30 for this event. So it will be roughly about 1 hour, I would expect. And yes, still the sound. This is why I was wondering where the sound was coming. Okay, so here, this is the program for tomorrow. So tomorrow at 10, we will continue with the wonderful poster presentations. So we'll have the next set of posters at 10. Afterwards, we'll have again this meeting room. I don't know if Erkin is in, if the meeting room is still open. I would expect so. So you can also go there, gather, meet some people, also beyond the posters, obviously. Then at 2 o'clock, we have a presentation about security for IT, IoT, and OT. At 3, we have another poster presentation. And then in the evening, we have another special session with another Turing Award winner. So Windsurf also won it, and Martin Hellman also won it. And this will be about ethical decision making, something that is also super important in the relation to any algorithms you're developing and you're planting into the world. And then afterwards, we'll do the closing. Okay, so then see you later tonight.